All right. Yesterday we solved equations or systems of equations by graphing. We just had to look at where they intersected each other. Today we do something very similar, except we just use a different method to solve them. Okay, so I want to remind you what substitution is, first of all. The method we'll use today is solving by substitution. And so the reminder is, if I had y equals 2x plus 1, find y when x equals 3. And all you would do is substitute, replace the x with 3. So y equals 2 times 3 plus 1. 2 times 3 is 6, plus 1 is 7. I want to show you, though, that graphically, I've thrown some graph paper up here, we could do the same thing if we were to graph these two equations. Most of us recognize, hopefully, that this is y equals mx plus b forms. That's just an equation. Y-intercept is 1. Slope is up 2 over 1, up 2 over 1. Making sure I get my line nice and straight here. So I'm going to draw him in there. So there is that equation. Now let me graph the line x equals 3. Now many of us may not know what x equals 3 looks like. Until right now my line's off by just a little bit. Maybe right about there, but hard to scale everything just perfectly. But x equals 3 means x is always 3. So where does the other line, x equals 3, I know it's not in y equals mx plus b form, because it is just saying that x is always 3. So here's where x is 3, right there. That is a nice vertical line. And so now I'm going to draw him in. And I'll move them just a tad. And look where these guys cross. They cross right here at x is 3. Has to be x is 3 because those are the only x values on that black line. And the y value is 7 right there if you were to look across. So there we've just solved this system, 2x plus 1 and x equals 3, by graphing it. But substitution was much easier. Just take x is 3 and plug it in. So we're going to look at the homework now. I'm going to do the odd ones for you so you can see how this works with more complicated equations. You will not have to graph today. Just be substitute and solve. So I'm going to do odds, and you guys get the even ones. I'm not going to do all the odds because it just gets redundant after a while. So if we look at this first system, we got y equals 6x minus 11 and negative 2x minus 3y equals negative 7. Now, just like in that first example or that prelude, it just said x is this. Well, we've got a system here where it says y is 6x minus 11. What we can do in substitution is take this entire chunk that y is equal to and substitute it in for that other y. Now remember, I've talked about the fact that when you substitute, you always want to put things in parentheses. So here comes my substitution. I'm going to show those parentheses. And y is now 6x minus 11. I'll close my parenthesis, equals negative 7. And by substituting, what I've created is a new equation that only has x's in it. And that's perfectly solvable. So let's just follow order of operations. We have to do multiplication first here. So let's distribute that negative 3. We'll have negative 2x, and that will give us minus 18x plus 33. Negative 3 times negative 11 equals negative 7. We got some like terms here. an x term, and an x term. They're both negative, so we just add those and keep it negative. It's negative 20x plus 33 equals negative 7. We'll throw that 33 to the other side, trying to get our x alone, giving us negative 20x equals negative 40. Divide by negative 20 to get the x alone. Undo that multiplication with division. X is 2. That's not so bad. So we know what x is, but now you got to go back and find out what y is. The beautiful thing is we have an equation here that tells us y is equal to 6 times, well, what's x? Well, we just found x down here. X is 2. So we put it in parentheses, put the 2 in for x, minus 11. That's 12 minus 11, which is 1. At the very end, though, you want to express your answer very clearly. The answer is x has to be 2. Y has to be 1. That's where these two lines cross, and we didn't have to graph them. Now I'm going to do a bunch of erasing here. You can pause the video if you need to see all that work. But let's check those 2 points. So I'm going to take the first equation, y equals 6x minus 11, and I'm just going to throw in the 2 for the x and see what I get. Y equals 6, 2 minus 11, 12 minus 11, y is 1. So certainly when x is 2, y equals 1 in the first equation. The second equation, I'm going to check that just a little bit differently. I'm going to plug in the x is 2. I'm going to plug in the y is 1. And I'm going to check to see if it does equal negative 7. If it does, then that also goes through to 1. Well, that's negative 4 right here, negative 3 right there, negative 4 minus 3 is negative 7. That does equal negative 7. So that is the point where both these lines have exactly the same solutions. Let's take a look at number 3. Actually, let's not. Number 3 is the same deal. Okay, we just substitute. We're going to take the negative 3x minus 5 and plug it in right there for y. I'm going to do that tomorrow in class so you can see it. Number 5 is a beautiful problem, but too easy. I'm just going to substitute in negative 2 for that y. I'll solve for x. Number 7 is a little bit tougher. The reason number 7 is tougher is because I can't substitute into either problem right now because it doesn't say y equals this number or this expression. It also does not say that x equals this expression or this number. So what we do is a simple process. Let's take that first equation. I could have chosen the second one. And let's solve him for y. In other words, just get the y alone. On the left side, negative 4 plus 4 is 0 x's, so y equals 4x plus 6. And now I know what y is, and I can plug him, substitute him into the second equation. So I go negative 5x minus, remember parentheses when you substitute. Here comes my 4x plus 6, end my parenthesis. And now I have an equation with only x's in it. Now be careful here, I got to do the opposite of all this because there's some distributing going on. So my next line looks like negative 5x minus 4x and minus 6 equals 21. We got some like terms here. X terms. It's a total of negative 9x's. Minus 6 equals 21. Add 6 to both sides, trying to get that x alone. Negative 9x equals 27. Let's divide by negative 9. Looks like x is negative 3. I know the x value where these two lines intersect each other. I have to find the y value, but I have a beautiful equation up here that tells me how y and x are related. It says the y value is 4 times x, which we now know is negative 3 plus 6. So negative 12 plus 6, the y value must be negative 6. And therefore these two lines intersect if we were to graph them. And x is negative 3, y is negative 6. And again, we could check those, plug it in, x and y values into each equation, see if they make them true. Assuming I did my math correct, though, we don't need to check them. And then our very last problem that I want to show you, and not even the entire thing because, again, we'll talk about some of this tomorrow. I've got two equations here. Number 9, negative 5x plus y. You can solve either equation for x or for y, but you always want to focus on which one's the easiest to solve for. And in this case, see how that y is by itself? It doesn't have 2y in front of it, or 3y, or negative 8y. It's just a single y. That means it's very easy to solve for itself. And I'll show you how. We just add the 5x to both sides. Y equals, now the 5x is on the right, minus 2. And see, as soon as you do that, you know what y is. You substitute him in. And so we get negative 3x plus 6, put parentheses, here comes the 5x minus 2, because that's what y is now, equals negative 12. And now we're off to the races again. Distribute, distribute, collect your like terms, and just solve for x. And that's it. Hopefully we have good luck with this. We'll talk about it tomorrow in class. But if you don't make it, this gives you good insight on how to solve by substitution.